All right. Welcome everyone to Cybersecurity with Python and the Microbit. This is day one or part one of a three-part workshop. Each workshop will be 2 hours. Those will be recorded and posted on YouTube, so you can watch them or refer back to them later. And also for folks who are interested in doing the at your own pace thing with this kind of workshop, it'll be available to them as well. We will also have, after the main presentation, we'll stop recording and have some open discussions. We've got some, questions for you if you have time to stick around for a little bit, and you might have some questions for us. Our main questions are going to be about, what do you see as useful? Is there anything additional that you think could be added to our current offerings and stuff like that? All right, so with that, what I'd like to do what I'd like to have you do while we go over some of the just general introductions is to set your Zoom up so that you can easily get to your python.microbit.org editor, or basically a Chrome browser. So what I have here that you're seeing on the left is me attending a Zoom workshop, and then on the right we have a Chrome browser with two python.microbit.org editors open. And so in order to do this, probably in the upper right hand of your screen, so it would be roughly here, but this presentation might be filling your whole screen, so it might be here. There should be a little view button drop down, and when you click it, there should be an exit full screen option. And once you've exited the full screen, then you can resize your Zoom window pane like this, with the presentation somewhat smaller, but I'll try to always keep it viewable for you. And then open up a Chrome browser, and on the other side, open up 2 tabs worth of python.microbit.org editors. And then plug in your microbits. Let's see, can you see me? Yes, you can. So then plug in both your microbits, either to 2 USB ports on the computer you're using to attend, or one on the computer you're attending and on another on a separate computer. I'd certainly recommend attending on that computer as well if you can, because otherwise it might be difficult to do some of the 2 microbit at once activities.
Excuse me, I have a question.
Yes.
Are we going to be using both microbits today?
That's the goal at the very end of the day. However, we didn't get there last time. So I'm going to try to go faster so we can do it. That is the goal. Yes.
Okay.
And as a matter of fact, we'll have a communication between microbits, just testing it fairly early on, probably about 7 slides from now, I think.
Okay. More than was in the instructions to get ready for the.
Oh no, it's just basically the instructions that you had, and I'll talk about this. I've got a slide for it. The instructions that you had said, okay, connect both microbits to your computer and make sure that they can both talk to your computer. Let's see how to summarize it. Make sure they can both talk to your computer. So that's what you did as part of the prep for attending today. And so the first or the next test we'll do is just to have one microbit use its radio to send something to the other microbit and make sure that they're talking to each other as well.
Oh, okay.
And then at the end of the session, there will be another application where we're chatting between terminals. Now, if for some reason your computer only has one USB port, or you don't have 2 microbits, don't worry about it. It's fine. If if you need to just work on that later or tomorrow or something like that, you've got my email address in case you get stuck on anything. So it's not a big deal if everybody can't do every single example that we do, hands-on as part of the workshop. How's that sound?
It sounds great. Thank you.
Okay, excellent. So here is the slideshow, and I'll copy the original link, and then let's see here. Chat. Paste. Okay, so I just pasted in a message to everybody of the slideshow. I'd like you to at least bookmark the slideshow because it's going to have a lot of links in it that I'll be following during the workshop, and that I'm hoping that you'll be able to refer back to as you end up needing bits of information. Okay, so with you today, we plan on having me, Ari, and Stephanie with us, but it's just me and Stephanie today. Ari couldn't join us this week, actually, and so I think it's going to be mainly Stephanie and me. Stephanie will be monitoring any chats, any questions that you might chat, as opposed to just unmuting yourself and saying, "Hey, Andy, I have a question." She'll answer or bring to my attention anything that might need to be she usually sees a question and goes, "Oh, Andy didn't talk about that. Let's have him stop and and talk about that." So that's us. About myself, I'm by training, I'm an electronics engineer, and while working at Parallax, I've ended up writing a lot of educational material, and most recently I've been focusing on the microbit with the Cyberbot robot that you see in the upper right corner, and then electronics with the microbit. And just last week, I actually came back around to some cybersecurity material and have a draft in progress that I'm hoping we can test out on Friday. About Parallax, we're just outside of Sacramento, California, on your way up to Lake Tahoe. We have about 20 employees, have been around since 1988, and putting together, supporting, and selling educational kits since '97. The main emphasis of Parallax is those programmable brains and circuits inside products. Or actually, I should say that's where our roots are. And so the upper row are examples of products that have microcontrollers that are monitoring and controlling circuits inside the product. And then down below are some kind of cool projects, including a mechanical millipede, one of the old Harbor Branch subs, and a drone kind of aircraft. All of those along the bottom have Parallax microcontrollers inside them doing certain jobs that help the thing function. Chip Gracie is Parallax's chief inventor, and Ken Gracie, his brother, runs the business. And Chip invented, back in the 90s, he invented something called the basic stamp. And this is the first microcontroller module that made controlling and monitoring circuits with a programmable device something that was more accessible than skilled technician, engineering student, or engineer level. And it became very popular. It essentially turned hobby electronics upside down. It was a huge change between what had been done before that and what people could do now that they had the ability to connect a circuit to something and program it. We started also making robots like the original Bobot robot shown here, that with student projects to use the basic stamp to monitor circuits and control the motor. Now, there were several iterations to get to the microbit, including the Arduino. And so basic stamp was the big hobby microcontroller, late 90s to early 2000s. Then the Arduino became the preeminent microcontroller for a while, and currently, at least in education right now, the microbit is definitely the most popular microcontroller for education uses. And here is an example of one of the links. Actually, many of these things are linked. So like I just went out of presentation view, and now oh, apparently, did I? Let's see here, escape. All right. So for example, each of these applications, you can click them and then follow the link to it. And then this link down here is a link to the Make It Code It microbit.org site, where all of these applications live. And so I'm going to focus. Well, let's do the step counter. So I'll go ahead and open that up. Send you chat you a link to it. Maybe I'll just show you. Okay, so here is the step counter, and it starts with a video. And then when you get down to the code, it's not immediately obvious, but there's make code, which is this block programming language. And then there's also a Python option. And you can click the Open in Python button to have all this open in Python. Thing is that it's going to open in the version 3 editor, and we're going to be using the version 2 editor for these tutorials. I'm hoping that we can get the version 3 editor. Basically, we have hundreds of pages of documentation about the version 2 editor, and so it's going to take a pretty significant time commitment to get those updated. So we're thinking at the soonest this summer we would be updating those. All right, so let's see here. I went ahead and just copied this, and so as you're looking on, I could, for example, paste this into my version 2 editor. So there it is, and then I'll also paste it into the chat so that you can do that too. And now that you have that, I would recommend copying it from the chat into one of your editors, and then you'll need to hit connect. Actually, I'd better demonstrate, since you'll have 2 microbits connected. I'm disconnecting my microbit modules from their USB cables. And what that should do is allow me to, when I hit connect, see about the same thing that you see. So I'll hit the connect button, and then you can choose your microbit. So I'll choose one ending in 144 for this editor window. And then I'll hit connect again and choose, in my case, one ending in 205 for this window. And then you can flash your code. And then one of your microbit screens will go blank. And the one that went blank is the one, or it may show a single digit. And so that's the one that you'll want to use. Or basically, you can just take both of them and give them both a shake, and you'll notice that one of them starts counting each and increments the number it displays each time I shake it. So it's a nice little step counter that students have fun mounting on their shoe to see how many steps they took.
Andy, we have a question.
Yes.
For Catherine, are all of these applications written in Python, or are there other versions too?
They are written in a variety of languages. Let me go back to the Make It Code It site. Here we are. So one version is MakeCode. So this is a block programming language that's used. Now, another version is Python, and this is the BBC published version of Python. MakeCode.microbit.org also has at least one other languages. So if we open this in MakeCode, I don't recommend doing this. This is just as an answer to the question about the different languages that are supported. We have our blocks here. Then we have JavaScript, and then Microsoft's version of Python, which is somewhat different from the BBC's. By the way, it's the BBC microbit. British Broadcasting Corporation is the one that distributed these to somewhere around 1 million middle school students as a way to encourage technology education in Great Britain. Anyway, so this is Microsoft's version of it. And then again, the BBC version is what we see here. And so the syntax is a little bit different, but they can both do most of the same things. So block code, Python, and JavaScript. And block code, 2 flavors of Python and JavaScript are the most common language versions. Now, if you go to the BBC site, there's going to be a page that lists a number of other projects. So you might find, if you have a particular language that you're interested in, just go to microbit.org. And then scroll to the bottom, and there will probably be something about, let's see, there's partners, board, there's development community. I don't know exactly where it's going to be, but basically, if you search around on the microbit.org site, you will most likely, let's code. I'll bet it's here. So, oh, look, they've got Scratch. They have a whole list of editors. So here, I'll go ahead and paste you in this link because this is a better answer to your question. Thanks for asking that, by the way. Paste. There you go. All right. Let me know if that was not sufficient. Otherwise, we'll go ahead and move on. Did everybody get to try the step counter? Can I get some thumbs up or thumbs down? Got 1 thumb up, 2.
Would anyone like more time to try it?
3, 4. Oh, excellent. Okay, yeah. Okay, looking good. So just give me a yell if you're stuck. Otherwise, we'll try send a smile next. I'll copy this and paste it in. Or actually, no, I'll just copy that. I'll just open the link and then I'll paste it to you.
Aaron replies that we were playing with a few different examples today in one of my classes when students had done their assigned work. Oh, that's great.
Yeah, the microbit, especially these make it coded examples, are just too much fun. They're a great icebreaker for a first week or so of class. Well, anywhere from a couple hours to a couple class weeks, just depending on how much time you have to go over the material. Anyway, again, we're going to use the Python, the BBC microbit version of MicroPython, and I'll go ahead and paste this in for you. And this one will have you put into both your editors and load into both your microbits. So I'm going to basically shade and paste, shade the whole thing, Control A or Command A, depending on whether you have a Windows machine or a Mac, and then Control V or Command V for paste. And we can do that on both. And then flash both. Oops. There we go. I accidentally disconnected and then reconnected one of the microbits. All right, so now they're both running. And what you can do is these microbits are both on the same radio network now. And so here we have, let's see here, this is the A button. And so when I hit the A button, I'm sending a smile. And I can hit the A button on this one and send a smile to it. And I don't remember, yeah, the B button doesn't do anything here because they just tried to keep it as simple as possible. So see if you can cause the smile to bounce back and forth between your microbits. And if so, it's a really good sign. It means their radios are working. And I've never actually had a microbit that didn't have a properly working radio. So, but it's a nice getting started little way of seeing some of the radio activity that you can have between microbits. So give me a thumb up as soon as you've got that running. Nice job, Sarah. Catherine, excellent. Kevin, good job. Aaron, excellent. Nada, excellent. Christine, all right. Okay, you guys are doing great. Do either chat Stephanie or unmute yourself and give me a yell if you're feeling like you're behind and having trouble getting caught up. Oh, nice work, Sandra. Okay, looks like we've got almost everyone. And like I said, either chat Stephanie or unmute yourself and let me know if you need extra time. Now, I guess an important thing to say about this Send a Smile is that this is the very beginning of how and why we can use microbit modules to teach cybersecurity lessons. It's because of the fact that they support radio networks. And so it's actually a really nice thing because this network does not require any kind of IT support. It's they're using the Bluetooth radio, so it's the Bluetooth frequency, but the microbits are using, for this open radio communication, they're using something called the Gazelle protocol. That's part of, that was created by Nordic Semiconductor, who made the microcontroller that's on the underside of these microbits here. There is some additional, so this particular resource came out of this YouTube video where I take a dive into the myriad of resources available through microbit.org, primarily targeted at middle schoolers, and then our material is a little bit more high school oriented. Okay, so what's coming up today? We're amidst the intros and overview still. I'll be talking about saving a file with the version 2 microbit editor, how to save and rename and reopen. We'll look at some of the scripting lessons that you may have, that I hope you either already knew or did as in preparation for this class. And then at the very end, we'll make sure that our microbits can communicate with each other through terminals using a chat application. So as far as how this might be relevant, how the microbits radio network might be relevant, well, there's a lot of extension in the lessons of saying, okay, you just did this between your microbits, and on computer networks, that kind of cyber attack might be, directed at a server. So it's not, you're not getting direct internet protocol type of experiences, but you are getting but students will get the experience of being on a network and having vulnerabilities to a number of different cyber attacks. And so what I did was I just added a few articles about, because the microbit is kind of close to an Internet of Things device when it's on its radio network. So I included a couple of articles that are that you can take a look at. about IoT vulnerabilities. And then another point of interest is especially, and this especially comes with the Cyberbot robot that has the microbit inside it, is it takes us to automation and robotics. And so Stuxnet, the Iranian nuclear facility that was disabled by a virus that was deployed, and I think that was the US and Israel together. That's an example of a cyber attack that affected some automation, and then also some missile launchers were also disabled a few years back through a cyber attack. And so these are the kind of things that that the microbit also makes a little bit more relevant, and it's a little bit it's something that doesn't quite get as much attention as, say, protecting corporate networks, but it's a very real thing. As far as cybersecurity educational resources, we have two different series. We'll be focusing on the cybersecurity tutorial series during this workshop. I'll show you a few examples from the Cyberbot robot. And but these are the two series, and they're very similar to each other, because what happened was the Cyberbot robot, we noticed that it was a superset of robotics and cybersecurity, and that was good. But we decided to take the cybersecurity security oriented portions of the Cyberbot and make it a microbit only option. So you have a microbit only option or a microbit plus Cyberbot robot option. And these tiles have links to the chapters in the cybersecurity series. And so there's two levels. The first level that we want students to go through is the computer science lessons. And writing microbit programs is one that I recommended for everybody getting ready, especially if you're new to Python. Usually after this first session is a certain amount of informational fire hose as far as kind of an overview of what programming lessons are introduced. And so I've realized that I need to talk about this, that writing microbit programs and then some of these other tiles here, like computer microbit talk, dictionary primer, exception handling, strings and characters, these are going to contain the majority of the basics of Python, and they certainly contain all the basics of Python that are needed for these tutorial series. And they contain most of the curricular checkboxes for computer science, learning to program in Python as well. So writing microbit programs is a very important link, and I'll be talking about this in just a bit. For those of you who are watching this on YouTube, this slide, the next three slides actually encompass the homework that the attendees did before the workshop started. So the first one is to make sure that your microbit will talk to your computer, and there's step-by-step instructions for doing that. And that is similar, by the way, to software setup for the microbit. So the links to the Google Docs that I gave you for preparation were kind of a fast track. The step-by-step student-based instructions are here in software setup for the microbit, and also kind of I sort of took elements from several of these chapters and put them into those Google Docs just to speed things up for you. But the students are expected to go step by step through here. For example, here's where we talk about the web editor versus an editor called Mu. Then we talk about, okay, go to the online Python editor. And it offers you to go to the latest and greatest version 3.0. Decline that because these tutorials, again, are targeted at this version 2 editor. This is python.microbit.org/v/2. So they'll go through here, they'll test the connection, they'll they're actually checking the microbit firmware. We happen to know that your microbit firmware is all up to date, so not to worry there. That's why you didn't see any instructions on that. And then they'll write a microbit program and then move on to the next thing, which is called add modules to your microbit. If you're, and this is for using the Cyberbot robot, or they may just move on to computer microbit talk. And then, of course, dictionary primer, exception handling, strings and characters. And these, again, are computer science. After that, radio basics and radio data are essentially setting up the network so that we can have cybersecurity lessons. And then encryption and sniffing attack. Encryption is step one in cybersecurity. Sniffing attacks is attacks and defenses is the next step, and then brute force attacks and defenses is the step after that. And we are adding this week malformed packet attacks and defenses, and I'm hoping some of you will enjoy trying that out maybe between Wednesday and well, it depends on how far we get. So I'll hurry up. But yeah, we'll in some way roll that out for you. And I'm just not sure how it's going to go yet. What I planned on doing was at the beginning of Friday, we were going to do some examples from there. All right. So the homework before the workshop, these are also the instructions on connecting 2 microbits to 2 editors on a single computer. And then, of course, if you have 2 computers, you'll just be finding one BBC microbit instance and connecting to that on each computer. After that, there was the basics of the very basics of Python programming. And so I assigned just a little piece, a little section of each one of these. And so, for example, if we did solve math problems, let's see, where is it? Solve math problems was one of the, by the way, communicate, remember, calculate, decide, and repeat. So those are some of the most fundamental programming tasks that can be done in pretty much any language. And so, whereas if we look at stuff like dictionary primer, exception handling, and strings and characters, those vary a lot more by programming language. And so we have, information and exercises and activities for students that are, specific to Python, because they're very different from their C language counterparts, for example. All right, let's see.
Any questions about anything in this area?
Okay, I'll take silence as assent, and but do jump in or chat Stephanie. Either way is fine. And for some of you, there's usually in your taskbar, there's a way to increase the power consumption. Basically, it becomes less battery friendly, but if you're plugged in, if you max the performance, on some computers, we've noticed that that makes a difference on how well the communication between the computer and the microbit works when we're doing serial terminal activities, which we'll talk about in just a little bit. Okay, so about Save Your Work. The main thing here is we have an application running right now. And we can go ahead and name this application, Send a Smile. So find the script name field in your browser editor, change it from microbit program to Send a Smile, and then hit load save and download Project Hex. Now, at this point, so again, and I want you to, if you could do this along with me, that would be great. So change the script name to Send a Smile. click Load Save, and select Download Project Hex. After that, go ahead and refresh that browser window, and confirm that it's okay to reload. And what's going to happen is your Send a Smile app is going to disappear, and and make sure to decline the new Python editor, and it will start with its default microbit program. So now you can also, so now that we see that, our work isn't on the screen, what we can do is drag Send a Smile from our download back into the editor window, and you'll see that sendasmile.hex, the Python app, comes right up. And if you refresh the browser again, it goes away. Hopefully you can see that okay. So this would be like Windows Explorer if you're in Windows. So this is Finder in Mac. Your Send a Smile app has been downloaded to your Downloads folder, and you can drag it from your Downloads or any old folder and drop it into the Python editor to also make it appear. And so that's a way to save and reopen files. And then there's also Load Save or Browse for File, and that will take you to your downloads, so you can open whatever you wanted to reopen as well. Okay, how's that, everybody? So that's, and then again, for anybody who's new to programming in Python, writing microbit programs, should be writing microbit scripts to make it Pythonese, covers the basics. And so again, we had you for homework go through communicate, recall, calculate, decide, count and repeat. And then there's some more programming stuff in here as well. And then like the push buttons, for example, fun stuff for the students. Writing functions is a little bit more programmy as well. So if we look at communicate for a minute, or no, I think I want to look basically at calculate. So we'll go to, now this is learn.parallax.com. I'll go ahead and show you how to get here and then paste you the link. So we start at learn.parallax.com, and normally I look at the Python language and then go to cybersecurity, follow that link, and that gets us there. And I'll paste that in for you. Chat. Paste. Okay, so this is your book with its chapters. And writing microbit programs is one of the chapters. And this is something that I also emphasize, is that it's best to have students set the tutorial side by side on the screen with their editor like this. And by the way, if you're having trouble reading this, one thing you can do is, with your side-by-side tutorials, you can drag the separators over to, so that your editor is a little smaller and the slides are a little larger. And then when you're working on your editor, you can drag it separate, or drag it so that the other way is favored. Another way you can do it is simply have them a little bit overlapping. Sometimes that's useful too, so that you have more room in this would be your Zoom, and then this would be your editor again. So these are approaches you can use to be able to see your stuff better during the workshop. Okay, so this is like a textbook. So we start with writing microbit programs, the cover page, and then it shows the contents here and here. And if we go to the next page, it talks about the LED matrix, and there's in this case, 3 subpages. And so you can keep on going through page by page, and you can also go to the previous page. Or you can use the table of contents to go to solve math problems, for example. And what I recommend trying to get the students into the habit of, usually through quiz pressure, is actually typing in the programs as they're getting familiar with the language. So they'd actually type in hashtag simple_math.py, and you can name it simple_math as well. And then start typing away, because what that's going to do is it's going to help the student move slower and think about it. The biggest death to learning programming is basically opening a pre-written application or copying and pasting it.
Hey, Andy,
Yes.
could you show them the printer-friendly button from the first page of the tutorial?
Thank you. Yes. So Stephanie is asking me to show you the, so anyway, side by side, for those of you who are new to Python, and especially if you're feeling intimidated, this is the way to go. It's not just for the students. And so that's really important. And then Stephanie wanted me to show you that you can also, there's a printer friendly version. It's actually on just about every page, but if you go back up to the contents, you can get a printer friendly version of the whole chapter. So here that is. So instead of having it be broken up into pages like this, now you have one contiguous web page with all the lessons. And so you can scroll through here and follow along in the same way. And this is also printable. Go ahead, Stephanie.
I was gonna say that can be saved as an HTML page and printed or opened up in Word and rearranged to suit the needs of the teacher. Our copyright is for educational use, allows teachers to adapt it to their programs.
Excellent. Yes, it's a very nice feature. And so you can also print to PDF, for example, save as PDF. And yeah, so that's another way to approach it. And so again, I probably for the third time, if you're new and getting your sea legs with Python, do make sure to put the tutorial side by side or printed, and work from said printout to go through and type in examples, because that's the best way to get comfortable with a language. And it also helps folks have ideas for experimentation and whatnot. All right, let's see here. Timing 1:46. So we're coming up on a 5-minute break at the 2 o'clock mark. This slide right here is kind of a basics review. And there's a little separator at the bottom of the slideshow that you can drag upward. And you'll actually see that in the speaker comments, this code is included. So you can try the various code examples. If a code example is not included in the tutorials, and this one is kind of like an all together now version of the tutorial we were just talking about, the writing microbit programs tutorial. So this is the key elements of it. And so we could paste it into here and connect our microbit and flash it. And it's going to give us, and now we'll open Serial. And now if this didn't work for you right away, you can close Serial and open Serial again. And that way it'll start from the beginning. And so the thing about this, I'll go ahead and paste it in now. That's the script. Let's see here. Is that the whole script? Let's see how much of it we got. Yes, that's the entire script. Sometimes Zoom truncates what I try to paste in. So you can go ahead and try that. And essentially what it shows is that for communicating, we're printing a message to the terminal, and that's this terminal with the open serial button. You can, when you hit open serial, it becomes closed serial. Then you can hit, so that's the way to toggle between your programming and the serial terminal. And so this is different from display.show. So like, for example, if I wanted to, so this only prints hello into this terminal here. If I wanted to see that hello in my microbit as well, I could say display.show. And it actually doesn't matter whether it's single or double quotes in this case. Either one creates a string. If you need a string within a string, in other words, if you need to display these characters, it's convenient to enclose them in double quotes. Like so. But for our purposes, that should work. So if I flash it, one of these is going to be displaying hello. Here it is. I'll restart that by pressing and releasing the reset button next to the serial input, or the USB port on the other side of the microbit. It's right here. You can always restart your script by pressing and releasing that button right there. Hopefully that's visible. So it's restarting the hello. And then also, if I open serial, you'll see it restart. Oh, I wonder what happened there. Close serial, open serial. Oh, I misspelled display. So that's an important thing, is if you have, if you restart your script and it starts with a frowny face, assuming, yeah. So here's the frowny face that it starts with. And then it tries to display a message telling you typically what line there's a problem on and what it thinks the problem is. It's kind of hard to read on here. So as a pro tip, if you open serial, you'll get the whole message. And so it's saying on line 7, it does not understand display. And yeah, that's not display. So let's try this. Flash. And now, instead of a frowny face, when I press and release that reset button on the underside, it should say hello. Yep. Okay. And so this also, this takes us through examples from each of those of the early pages in writing microbit programs. So here's remember, where 2 variables or 3 variables get values, and then each one is displayed with the print statement. Oh, I'm sorry, four variables, 2 integers, 1 floating point, 1 string. all displayed just by saying print and then their names in between parentheses, separated by commas. Calculate, very simple. Hopefully there's no questions there. We have C equals A plus B. And so we'll get, it will display C equals, and then the value of C. Well, C is A plus B, so that's 2 plus 5. So the result displayed here will be 7. And then deciding, looking at A and B and saying, hey, if one is greater, print that it's greater. If A is greater than B, if B is greater than A, print B is greater. Otherwise, print that they're equal. Then repeating has two common formats. One is to repeat a certain number of times. This one goes from 1 to 9. That's one of the tricky parts of MicroPython, is that it includes the starting value, but it excludes the ending value. So it starts at n equals 1. And so it'll say n equals 1, n equals 2, etc., up through 9. Then it'll say entering endless loop, sets n equal to 10, and then continues counting. So if I flash and then open serial, these basics, I'm going to toggle it. There we go. Okay, so it prints hello. It displayed our 4 variables. There's our C equals 7. B is greater. Counted up to 9, remember, because it's inclusive of the first argument in a for in range loop and exclusive of the ending argument. And then it displays entering endless loop. And then here is the endless loop where it keeps on counting every second. So hopefully this will provide a nice summary for some of you, or have your students create something like this. This is not part of the actual tutorials. All right. Moving on, this one's kind of fun. This one also is an example that Computer Microbit Talk is a chapter about how to use the terminal, like I was just showing you. And it does some more than I'm going to talk about today. But what I'd like to talk about from this chapter is the countdown timer application, because this is an application example. First of all, it's smartwatches have countdown timers built in, and you can use your phone to tell your smartwatch, how far to count down. And so this is one of several applications that are repeated throughout the cybersecurity tutorials to demonstrate how a distributed version of this has vulnerabilities and how those vulnerabilities can be hardened. So there is the countdown timer script, and then I'll also paste in this web address, although it's right here in the computer. Oh yeah, I should add the web address to input and print for applications. So if you go ahead and try this one, Command A, Command V, whoops. Need to get the script out of the chat as well. Okay, so copy from the chat. And Control A, Control V, flash. So after you flash, open serial. And if you get a bunch of stuff here, you can close and then reopen again to clear it. And then it'll say enter seconds to count down. You can do something short like 3. And then enter message after countdown, and we can do liftoff. And so here we have a countdown timer in action.
Andy, I have a question.
Yes.
Catherine asks, what does it mean if a red light on the opposite side of the cable from the reset button is flashing red nonstop?
So we're talking about this red light flashing red nonstop.
I don't think we can see you pointing to something.
So my thumbnail is not appearing. Okay, let me.
Oh, I'm seeing, it might be, I was not looking at you. There we go. Okay, yes.
Is it this
yes,
one right there?
Yes, that's the light.
Okay. I'm not sure. Let's see. That's let's ask the internet.
Catherine,
What?
is your program not loading or not giving you expected results if it loads? Can we have a little more information, Catherine, of what else is happening along with that light blinking? It has stopped now, but nothing was working when it was flashing. So the light has stopped blinking and you reset everything. Is it working now? If you try to run a simple program now? Oh, you ran countdown after that. Okay, and it works good. So I'm glad it doesn't mean there's anything permanently wrong, but it sounds like it might be some sort of error situation, communication error situation.
Okay, and so for those kind of things, my go-to is support.microbit.com. Oh, I typed that in wrong, apparently. I'll just go to it from Google here. Oh, support.microbit.org. Pardon me. Okay, so I almost fell prey to a phishing type of attack there. So support.microbit.org, we'll go ahead and put that in your chat.
This might also apply for Sandra, who's mentioning that hers is not working the countdown program.
Okay, so Sandra, what I'd like you to do, first of all, is if you're able to flash it like that by clicking the flash button, and if you open Serial and you don't see any messages, try closing it and then reopening it. And let me know if that gives you anything.
Okay.
Sandra, are you trying to talk? Okay, it
Oh,
works.
yeah.
You're cutting in and out.
Yeah, we're not hearing you, Sandra.
I do have a chat that says, okay, works now.
Oh, excellent. Okay, perfect. So, and again, this one is repeated in various incarnations throughout the series because some of the coding is going to become challenging. And so instead of throwing out a new application and having them, do a new cybersecurity technique with it, we instead move forward with a number of familiar applications just to keep it more approachable. Very quickly, before we go on a short break, there's a help button here. And so, for example, so as not to fall prey like I almost did, you can click the help button and select support. I forgot about that. You can also click the help button and select documentation. And this is really great because you might be looking at an application like maybe okay, so let's say you see button A is pressed in an application and you haven't necessarily seen that in a tutorial. You can basically search that here. And it will show you a number of pages where that is featured, and you can read through and see if you can find, essentially an explanation. And as I'm scrolling down here, I'm seeing buttons. That looks like a place where, I'd learn about button is pressed and button was pressed. And so I might go to that page and read about how it works. Okay, and with that, let's go ahead and take a 7-minute break. We can make it 8 minutes, actually. Let's come back at, it's 3 past, 7. It's 3 past the hour. Let's come back at 10 past the hour.
I will be here and the recording will continue during the break.
Okay. Yeah, so I should probably have had a slide saying back in 10 minutes. Let's see here.
Andy, are you going to step away?
No, how about you?
I'm good.
Okay.
I can see you making a slide.
Yes.
Okay.
How's that?
Perfect.
Okay. And for any of you who are not taking a break and have any questions, feel free to jump in.
Actually, while you're here, I will step away for a moment. Be right back.
Oh, okie dokie.
All right, I'm back.
Welcome back. Again, for anybody who's still at their computer, if you have any questions you want to ask during halftime, we are still recording. And then again, we'll also be here afterwards to talk about questions offline after the recording is stopped. I'm going to give everybody another minute. Okay, we are now at 11 past the hour, so shall we resume? Okay, here we go. So this slide, again, I already showed you by essentially clicking help and selecting documentation. That again is how you get to the microbit MicroPython documentation at this is an official BBC doc, even though it's not at microbit.org. It's the place where the documentation is kept for MicroPython with the microbit. And then there's a functions tutorial. And again, that's no longer a basic programming task. This is an example of something where we're making our script more powerful. And what I did was I included several things to try. I think I just want to talk about these as opposed to have everybody try them, but they are, if you drag that divider upward, you can see each one of the example scripts. And so you could try that if you like later. And also, since there's an entire functions activity, so in writing microbit programs, there's the basics, but then there's also writing functions right here. And so this is where the students would be getting familiar with writing functions. So it's right in the table of contents as a link. It's just one of the later activities in that chapter. So what I'll do is I'll just talk about this one right here, since it has, well, no, we better start with this one. So here on line 4 is a functions definition. And so this is not, as the microbit's going through, it says, okay, that's a comment. I'm skipping it because it starts with a hashtag. Then it says from microbit import star, and that imports, that brings in from a microbit module stuff that pertains to the microbit, like checking the push button, like display.show, all those kind of things are in from microbit import star. And so without that, you might have it might show you an exception error if you were to say display.scroll and then your message. But once you add it back in, it'll be fine. Then we have a function, and the function's name is function. So creative. And then the function just prints a hello message to help the student know that it's from the function. Then this line is really part of the main program. And so it prints hello from main. And when we get to line 9 here, it says function. And what that tells the script to do is go find the function definition, do what's in it, come back, and then keep going from there. And so, so after that, it'll print hello from main again. And so what you see as you're going through here is print hello from main. That's what you'll see in the terminal. Then function, which is hello from function, and then comes back. Well, there we go. Hello from function, and then print hello from function again. There we are. So that helps students get the idea of how a function call works in the context of being added in with several other statements that are executed one after another from top to bottom. Now, going for the more complex version, so this would be closer to the end of the chapter. Let's see here. All right, there we go. So things you can do with functions are give them parameters. So this function has a parameter named value. Its name is increment. And if we look down here, increment of 5, well, that 5 gets plopped into the value variable, and that's a variable that's local. So it only survives, it's only alive while it's in here. So here we have 5. We're declaring k to be 3. We're printing the value of k. It's going to show us 3 inside the function, even though there's a value of 10 outside the function. This is called a global variable. And then these are local variables, value, k. And so we see here that k is 3, just like that. But then later on, it's going to print the value of k. And since we're not in that function anymore, we'll get this global k. So it'll show you 10 at the very end, right there. And so that's a lesson about the concept of scope. And you can have more than one parameter, like this add value 1, value 2. Well, we can say add 5 and 6. Goes up here, adds them together, returns the result. And the result of add 5 and 6, this will become 11. And so it's going to print add 5 and 6. And the result that comes back from add is a return value, and it is 11. Okay, how's that for a whirlwind on functions? Everybody okay there? Any questions? And again, you can try these out because they're right in the slide notes. And I'm going to jump past objects and only come back to it if time permits, because we're not currently using objects in the cybersecurity. We're stopping at, well, we are using, yeah, we're using modules, so I'll have to talk about that. But basically, there's an objects lesson here. And again, it's something where if you pull up the slide notes and wait for a second or a few seconds, each of those will appear, and you can create an object and basically it's both of these script examples. This is one where you'd want to use the version 3 editor, because in the version 3 editor, you can actually create a module and edit it. And so, this is a module called adding. And so from adding, import star gives us the functions inside this, I'm sorry, the method inside this module. And what that does is it makes it so the user code is really clean. You can basically say, you know, A is the result of the adder function and B is the result of the adder function with a different, basically that this example allows you to press the A button to increment by 2 and the B button to increment by 3, and it just shows you that. And so this is made possible and simple by having some code tucked away in a module. And so a module is like a plugin that has extra functions and methods and data that you can use in your code. And the main plugin that we've been using so far is from Microbit Import Star. Another plugin that you're likely to see is in add modules to your microbit. Now, this is only for the Cyberbot robot. You don't have to worry about this if you're not using the Cyberbot robot. But if you are, essentially, this add modules to your microbit is a way to get access to the functions that are needed to make the Cyberbot robot roll around and measure its sensors and those kind of activities. So I guess I'll take a second to talk about the Cyberbot robot. Learn.parallax.com. Python Cyberbot. Here's the Cyberbot series. So it's just, again, it's a superset. It's the cybersecurity lessons plus the robot stuff. And so when we look at navigation with the Cyberbot robot, maybe you're running this forward and backward script right here. And what you'll see is from Cyberbot import star. And then there's some documentation, which I can go back and show you, but this will say, hey, bot of 18, set the servo speed at 75. And then that's a motor connected to a numbered port on the Cyberbot board. And then there's a different port with a different motor for the other wheel, and we'll set that in the opposite direction, and it makes the robot go forward. And so these are examples of methods that come with the Cyberbot module. So modules, again, are like plugins that give your script extra features that you can use. And each module has an API, which stands for Application Programming Interface. And that is going to be back in Add Modules to your microbit, Cyberbot Library Reference. And so this lists all the different features and talks about how to use them. And that's just an FYI of modules that when you're importing something, it gives you extra features, and just to be aware of that. And especially if you're using the Cyberbot robot, you will need this because of primarily the servo control stuff. And the servos are the motors that make the Cyberbot roll around. Okay, so moving on.
Before you move on.
Okay, go ahead.
From Aaron, as far as skills transference, if we're planning on using the Arduino robots in the class setting, what would be the difference in Python versions for it and microbit?
the difference would not be in Python versions. It would actually be a difference of C versus Python. So if you're programming the Arduino, you're going to be using C language. So going to the, so here's the Arduino ShieldBot lessons. And taking a look at the textbook, let's see if I can find a good, well, we talked about motor control. So let's see here.
Well, I guess there are ways to program an Arduino in Python.
Okay. Yeah, I'm not aware of those. Oh,
Editors, but that's not how the ShieldBot tutorials are presently supported, at least.
yeah. Yeah, I'm a little bit behind the times on that. Yes. Okay. So there may be a Python option, but we don't have the tutorials just focus on the Arduino C++ in a wrapper programming style. So
If someone's interested in adapting that, I did find an article on the subject from Arduino CC about using MicroPython on an Arduino board.
oh, cool. Could you paste that in?
I just pasted it into the chat.
Thank you.
That could be very interesting.
Yeah, so here's a quick look at the C++ language that's used to make the Arduino ShieldBot go. I guess one other note about that is that if you have the ShieldBot chassis already, if we go back to learn.parallax.com and then to the Cyberbot, there is a convert to a Cyberbot. So you've got the same chassis, servo motors, wheels, and tail wheel on the ShieldBot that is on the Cyberbot. And so if you wanted to offer, two different flavors of robot programming, you could just get the conversion kit, which is the Cyberbot board, the microbit, and Stephanie, what else is in there? I don't think very much.
I just sent the page over.
Oh, thank you. This one?
Yeah.
Okay.
It just makes sure that you've got the correct battery pack in case you have a Bobot. And then most of the expenses in the board that has the propeller on it and the firmware and so forth.
Yeah. Yeah. So this is the microbit microcontroller. And there, by the way, next to the magnifying glass is the reset button next to the serial socket or the USB socket. And then the Cyberbot board is, here we go, is this guy. So that's a little bit about modules. And these just a little bit more nomenclature is on this slide. So this is importing a module. Display.scroll is an example of calling an object's method, and that object is in the microbit module. And then sleep 2000, which waits for 2 seconds, is an example of calling a function that comes with the microbit module. And image.heart is an object, is a property that's inside an object. So that's just a little extra nomenclature that I wanted to give you a slide for in case you need it. Lists and tuples are simply ways of keeping lists. They are very different from C language, though, in that they, standard C at least, in that they have special features. So for example, if you say that you have a tuple, which is a list of things enclosed in parentheses, and a list is a list of things that are enclosed in square brackets. The only difference is that if you create a tuple, it cannot be changed, whereas the elements in a list can actually be updated or changed. And both of these also have special properties in that, like here's an example of, we have a list named LIS, and we can take list of the second element 0, 1, 2 inside the list, and we can change it from high to by, and it will actually, you know, after we display the list again, it was high up here, and now down here it's by, right there. And so that's a cool thing that you can do. And there's also some extra features. You can actually find things in the list and ask what their index is. And then here's a cool one. You guys can try this. It's an example of using a list to play musical notes. And let's see, I'll go ahead and copy this link, and then you can copy and paste from here into the microbit. I'll demo it first, and then I'll paste in the link. Okay, so if I follow the link, here we are at music, and we don't actually need this because we have speakers built into our microbit. So here is the example. Had to scroll down to get it. So I can copy this and then paste it into my Python editor. Make sure to paste it over whatever application you had in there, and then flash it. Is that audible through the speaker, or is my automatic gain control filtering it out? Stephanie, can you hear that?
Nope.
Wow. It's pretty loud and clear for me, so I'll let you guys try it. That's amazing. So now I have to send you guys this link. Copy, chat, paste. There we go. Maybe somebody else can put it up to their speaker and unmute themselves, and so we can hear it. Please go ahead and give me a thumbs up once you've got it playing some music. Awesome, Kevin, Catherine, good job. Sarah, nice. Christine, excellent.
Got a thumbs up from Ernesto as well.
Sorry, I missed you, Ernesto. You're on the second page of.
It's in the chat.
Oh, in the chat. Okay,
Yep.
Thank you. All righty. Okay, so that's an example of a list, and it's a pretty involved one, but this is a, you know, it's and you can, in this case, the list is named notes, and it's passed in its entirety to music.play, and then music.play, we're importing the music module there. And so play is one of the methods, and notes is a list that we gave it, and it played the list as it's designed to do. Another fun one that we'll skip in the interest of time is simply pressing the A button and randomly selecting one of your to-do list options. And the to-do list is in a list named options. Kind of fun though. Yeah, I included the link if you want to go there and try it out. Next in the computer science area is the dictionary primer. Dictionaries are especially relevant because they are a convenient way to exchange data between devices. So if you create a dictionary, you can send it from one device to another. In terms of web browsers, It's often referred to as JSON data. So JSON data, if a web browser sends some to a server or receives some from a server, like if you do a search, that's going to get put into a JSON package and sent off to Google, and then Google will send you the results back. And so all those kind of things and many more are the way that data is exchanged between separate devices on networks. And so, so the dictionary is simply the Python name of the same thing. If you look at JSON data in a browser's developer tools, you'll actually see it has the same format where we have a key and a value, or pardon me, a key and a value, and they make up a key value pair. And some things about dictionaries are that you can say, okay, go and find the key score and give me the value and put it in the number variable. And so it goes and finds score and plops 1000 into the number variable. Or you can change one. You can update the score, for example, by saying info of, and then score, and then giving it a new value. And then this 1000 will be replaced by, in this case, 1, 2, 3, 4. And so that's kind of a summary of what students do in the dictionary primer. In the, let's see here. Sorry, I forgot about this one. What are we doing here? Oh, this is the dictionaries activity. So this is if you're running the script that is stored down in the comments. Again, in the interest of time, if you guys are okay, well, let's get some thumbs up and thumbs down. Do you guys want to do that or just move on? I really want to get to the radio communication stuff today. And so I was hoping on just keeping it at kind of a summary level, but if you really want to try out dictionaries, we can do it. So thumbs up if you want to try the dictionaries, thumbs down if no. Okay, got one thumb down. Thank you. Two, okay. We got one thumb up, two thumbs down. Tell you what, I'm going to put it in the chat and you guys can try it out, but just go quickly. I'm going to keep talking while you're doing it. So just kind of keep an ear on me as you try it out. If you're inclined to try it out, chat. Paste. All right. And so what we see here is again, this is from one of the student activities, and it basically shows the different operations that you're performing on a dictionary. You can check the dictionary, you can change its value, and you can even add an element to a dictionary. Exception handling becomes super important, especially with the forthcoming malformed data packet attacks and defenses chapter, because this is kind of a go-to as to how to make sure that nothing stops your microbit in its tracks. Because the microbit, when it's interpreting a script, if it runs into something that's not right, like a bug or one of its programming rules is broken, it actually stops, displays the message of the error it encounters, and then doesn't do anything until you restart the script. And so the way to handle that is with try and putting the statements that might break the script in there, and then instructions on what to do if the microbit does run into an exception, what to do if it doesn't, and then what to do regardless of whether or not it ran into an exception. And what this does is it keeps the script running even when the microbit runs into an exception. And so this is an example in the chapter of a script that can easily be broken. And basically what we do is we take this denominator D value, where quotient equals numerator over denominator. Just take that D value and change it from 5 to 0. And then this line will cause an exception. And then as we go through here, by putting that math calculation inside this try statement, then this shows, hey, here's how to display the exception if it occurs, or just, show the result of the math, and then tell the user to try the script again by restarting it, by picking new values. And so this is the kind of thing that students are learning in exception handling, and it gets them ready for stuff that comes later. Also, if you're sending information from one microbit to another, and the other microbit is expecting a certain format of stuff, and instead it gets, like, if you accidentally give it a letter instead of a number, that will cause an exception to occur. So even if it got the data, it might still choke on it. And so it also is presented as exception in the exception handling chapter. It's presented as, hey, remember that annoying time that your browser froze? Well, here's why it happens and here's how to prevent it. But then later on, it's, hey, attacks can use, cyber attacks can use these as well. And so that's coming up. And then the last thing is simply using exception handling to kind of target, figure out what the problem is, and then give the user some prompts as to what they did wrong. Like, can't divide by 0 is a custom message. It's a customization of the exception handling. So those are the kind of things that students get to learn in exception handling. And then strings, there's lots of good stuff in strings, because strings are objects that have a bunch of functions that can work on them. And also they are objects in and of themselves, and they have methods that you can use to perform operations on the string. And so what this is showing on the cover page is, hey, here we have a string, and we can take that string and do string surgery on it to make it a different string. And now we get to the bidirectional texts. So let's try this. I think it's a lot of fun. Basically, pandemonium ensues, and this is a thing to, as soon as the students start interfering with each other's texts, it's a good place to be able to talk about, all right, guys, we just saw things kind of devolve here, and this is an example of how cyber attacks can happen. And so that's why we're going to do some more of these lessons to help protect yourself from being flooded with messages and various other things. So this is the bidirectional texts script right here. I'll give you the web address first. And then we will, let's see, then we'll give you the actual script.
Is someone trying to speak? I'm hearing something like maybe it's not coming through. Go ahead and put it in the chat if you'd like.
All right, so here is, so I just pasted it into the script or into the chat. And this is one where you'll want to paste it into both editors connected to both microbits. And flash both of them. And then open the serial terminal on both of them. And it's probably a good idea to tile them side by side. So after you watch here for a second, what I'm going to do is just start over by closing and reopening serial on both of them after I've flashed it. And essentially, when I type a message into here, it's going to go across the radio waves to the other microbit, and it will, oh, you know, one thing that I prefer to do is update the name of the microbit. Like this is microbit A, and so we want to make this one microbit B flash. Okay, and so you can type hello here and hit enter, and notice that hello appears over there. And on the other microbit, I can say hi. And then here it is over here. And so students can pair off or get into small groups and have a nice little chat session. And this is another application like the countdown application. It's another one that gets repeated throughout the series as a thing that you want to protect your data with. And so it appears in encryption and in sniffing attacks, and I believe also in brute force attacks. And so how is that working? Basically, you type a message into one terminal, it goes through USB to that microbit, it goes out that microbit's radio, into the receiver microbit's radio, up its USB cable, and then into its terminal. So it's not that it was that I typed this and it went through the computer to via USB to the other microbit. No, it went over the radio. And so if you have two separate computers, this application will still work. However, there's a length limit on how long your string can be. But you can get past that length limit by modifying it slightly to give it the maximum available buffer, which if memory serves is 254. Oops. I made a mistake there. Let's find out what it is. Okay, it's shorter than 254. It might be 253 or something. We'll just say 250. I'm pretty sure that that'll work. Yeah, okay. Let's see if that makes it. Oh, wow, look at that. I'll go ahead and paste the updated script into the chat. There is the updated script. And if you could show me some thumbs up and down if you were able to get that running, because that's going to be a crucial one. Excellent. Nice job, Catherine. Excellent job, Ernesto, Aaron, Sarah. Oh, you guys rock. Nada. Way to go, everyone. Kevin. Sarah, Nada, Kevin.
Christine says got it also.
Oh, thank you, Christine.
Anybody stuck?
Give me a thumbs down if it's not working for you? Doing okay, Sandra? Excellent.
Working,
Thank you for the confirmation. Perfect. Okay, so just stop me if you, at this point, we could also just help you out after the session. All right, so this is an example, one example of something to protect. We have a few minutes left, so let's also try. So I'm going to skip the homework here. Let's take a look at, so yeah, we were going to do radio data at the beginning of the next session, and then encryption, sniffing, and brute force, and then hopefully we'll finish brute force, and we'll just do so we'll do malformed packets here. As far as homework goes, I don't really think I want to give you much homework with Valentine's Day coming up. Let's see what we had here. We had you do bidirectional texts, but we just completed that. So we're good there. Oh, so here we have some optional homework. Basically, what I did is gave some links and some further reading. So if you're interested in finding out more about some of the stuff that I just sort of gave an overview of how it works, go in and try this. It's all optional. And so that'll hopefully free up your Valentine's Day. And since we have 10 minutes left, we can go ahead and hit radio data. So this is radio basics again. Here is radio data. And so all radio data really is, and we use the countdown app that we did earlier to demonstrate it, but instead of doing it on one terminal, now we're doing it in a distributed fashion over a network where the information you gave it, like the countdown starts at 3 and then you say liftoff, those get put into a dictionary. Then that dictionary gets sent, goes through the USB to the microbit. Microbit puts it into a dictionary, sends it across the radio waves. The receiver gets that dictionary, parses it, and then does the job for you. And so this is an example of, devices communicating with each other, browser to server. It all is similar in concept to how this is going to work with JSON data being moved around on a network. So let's go ahead and try this application. Send and receive radio packets. So I'll give you the link here and paste. And what I would like you to try this time is you'll be on your own. I'll just give you the link and we'll have you take the sender script and paste it into one microbit. And then we'll have you take the receiver script and paste it into another microbit, or into the editor connected to the other microbit. Flash them both. Open serial for them both. I'm going to close and reopen just to make sure I start with a blank slate on both of them. Okay, so we'll make the countdown start 4 instead of 3. And after the countdown, oh, actually, Happy Valentine's Day. What did I make a mistake on? Line 22, invalid syntax. Close. Let's see. Oh, you know what? I made that message too long. So this is the same thing that happened earlier. To say Happy Valentine's Day, I'll bet I need to increase the length of the buffer a little bit. Five. Still a problem. Let's do something simple. What am I doing wrong here? Countdown start. 3. Kaboom.
Are you missing a closing bracket? I can't see from here.
Yeah, I don't know, but I need to restart this. So another way to restart your script is to close serial and reopen it. Okay. Okay, so that worked. Great. I don't know. Maybe 3 exclamation points killed it.
Catherine reports, I copied the code right from the lesson and it works with Happy Day.
Excellent. Yes, yes. And if you want to, instead of do Happy Day, do Happy Valentine's Day, in the receiver's radio config, just add length, comma, length equals 100. Or you can even say 250 just to give yourself maximum flexibility.
I have a question from Sandra. Am I unclear what flash and serial mean? Maybe
Okay. Probably because I haven't talked about it. That's a really good question. So Flash is actually a kind of memory, and it's an acronym for its design. And so if you have a flash drive, like a USB stick, a thumb drive that you plug into your USB port as a little extra hard disk for your computer to store data off the computer, that's the kind of memory it is. And the microbit has some. And what they're doing here with this flash button is they're actually using it as a verb, saying, load the script into the flash memory. And so that's what flash is in this context. And then serial is short for serial terminal. And basically, there's only a little bit of actual serial communication happening. I'm going to put the video up so I can see. No, let's see. How am I going to do this? Serial. Let's see. Microbit, edge, connector, site, microbit.org. Edge connector pinout. I'm just looking for a good picture. Oh, that isn't even a good picture. Let's see here. Want to get a good picture. Oh, I know. How about parallax.com? Bear with me. I'll find you a good picture of the microbit. All right. So we'll do a search for microbit.
You can go to the 32717 page or the 32715 page. If you search for 32715, I think that'll give you the best image.
Okay. So here's 32717.
Try
32715. Here we are. Okay, so here's the front of the microbit. And here's the back. Now, this microcontroller is the one that executes your script and sends serial data. Now, what serial data is it's just a pattern of high and low electrical signals that carry information with them. And those electrical signals get sent to this microcontroller, which its main job is just to make the microbit look like a flash drive and also communicate over the USB to the computer. So the serial communication actually happens from this chip to this chip. And after that, it's all USB until actually we get to the terminal. So that's this area right here where we can type messages back and forth. And in the computer, in the old days, this used to be that same kind of electrical signal. There used to be something called a serial port, which we don't have anymore. And so this is essentially emulating a serial port when I type in 3 and then happy day. And there we are. And then in this serial port, here it counted down to happy day. Did that help? How's that for an explanation of serial and flash?
Well, I understand flash now, it makes perfect sense, but I'm still a little unclear about serial. Is that like saying run the program?
No, what serial is it's just a type of electrical signaling between computers over a wire. And computers used to have serial ports. They had 9 pins. And the serial data was transmitted over one wire and then received over another wire. And the electrical signaling defined whether a binary 1 or 0 was transmitted. And that's how all the text went back and forth between, say, a computer and a modem back in the day. And now this serial terminal is just basically, like I said, all the serial that's happening is between this chip and this chip. That's the only place where electrical serial signaling is happening. But this is emulating the serial ports of old.
So when you're
Go ahead, Stephanie.
So when you're hitting that open serial, what you're expecting is for that little window to open on the computer where it can look at the text messages that were received as a serial communication method and interpreted into the script, right? And that's using the ASCII codes?
It's using ASCII codes, but before I get to ASCII codes, I just want to point out that the print statement is what sends the characters to the serial terminal as opposed to display.scroll.
So for serial, you're talking to the window that opens up on the computer. And for display, you're talking to the little grid of LEDs on the microbit.
Yeah, the LED matrix right here.
Okay.
And then let's see here, back out. There we are. Also input. So input is another function that talks with the terminal that comes up when you hit open serial. And input basically allows you to click the terminal, type characters, and then those characters come to this input function. And then whatever characters you type get stored in text. And hopefully those characters are an integer value, because then it converts the value to an integer and stores it in value. And then the message like happy day is also captured by an input statement and stored in a variable. And then that's what's used to assemble the dictionary. And then the packet is just a stringified turned into a string of characters version of the dictionary that then gets sent out over the radio. And with that, I think I'd better call it a day on the recorded presentation, and we will continue with any questions and answers as pretty much as long as you want to go after the recording stops. So we're not saying go away. Stick around. Tell us what you like, what you don't like, what any questions, any further questions that you have. And I will email you the information that was on the homework slide. And again, that homework is optional. Have a happy Valentine's, everybody, and we'll go ahead and stop recording and then continue the discussion.